Okay, good morning students. So we discussed in a last class, so the topic is mechanical properties of solids. In mechanical properties of solids, so what is the stress and three types of the stress? That is called as a longitudinal stress, okay, so bulk stress and volume stress or shearing stress, etc. we discussed in a last class. And so what is the strain? Three types of the strain: longitudinal strain, bulk strain, shearing strain, etc. we discussed in a last class. Okay, so today discuss the another topic. So what is the Hooke law? Hooke law. Okay, so Hooke law means, so within the elastic limit, the stress is directly proportional to strain. Stress is directly proportional to strain. Okay, the stress is directly proportional to strain is called as a Hooke's law. Okay, so within the elastic limit, the stress is directly proportional to strain. అంటే మనం ఎంతైతే బలాన్ని ప్రయోగిస్తామో అంత స్ట్రెస్ కు లోను కావాలి. ఓకేనా? అంటే స్ట్రెస్ is directly proportional to strain. Stress is increasing, strain is increasing. Only within the elastic limit, so that is called as a Hooke's law. Okay, so the rubber is taken, so the some external force is acting on the rubber. Okay, so within the elastic limit, the stress is removed, so it is regain virginal shape within the elastic limit. So that is called as a Hooke's law. Okay, so we can write the stress is directly proportional to strain. The stress is directly proportional to strain, and stress is equal E into strain. Okay, so E is called as a stress by strain. So E is called as a modulus, elasticity modulus. Elasticity modulus. Elasticity modulus, that is called as a E is called as a stress by strain, is called as a elasticity modulus. Now is taken another topic, that is called as a proportionality limit. What is the proportionality limit? Proportionality limit. Okay, so what is the proportionality limit? Now here the stress is applied on the wire. The maximum, the stress is directly proportional to the strain. Okay, obey the Hooke's law. Okay, E is called as a proportionality limit. So the maximum stress is applied on the wire. The stress is directly proportional to the strain, and obey the Hooke law. E is called as a proportionality limit. And also we discuss the another definition, that is called as a permanent set. Permanent set. So what is the permanent set? So permanent set is nothing but, so the stress is applied on the wire beyond of the elastic limit. The stress is applied on the wire beyond the elastic limit. So it is a deformation complete. So the deformation is produced. So that is called as a permanent set. It is does not obey the Hooke's law, and is permanently, and it is beyond the elastic limit, is called as a permanent set. Permanent set, that is means శాశ్వతమైనటువంటి స్థితి. And also breaking stress. What is the breaking stress? Okay, so breaking stress, the stress at which the wire is a break. So that stress is called as a breaking stress. Okay, got it. Now here see that, so what is the Hooke's law, what is the proportionality limit, what is the permanent set, what is the breaking stress. So here see that Hooke's law means the stress is directly proportional to strain within the elastic limit, is called as a, okay, Hooke's law. And so what is the proportionality limit? So proportionality limit means, okay, so the maximum stress is applied on the body is directly proportional to the strain, and it is obey the Hooke's law, is called as a proportional limit. What is the permanent set? Okay, so the deformation produced in the body beyond of the elastic limit, Okay, complete permanent setup, that is called as a permanent set. And what is the breaking stress? So breaking stress means the wire is breaking at which the stress is called as a breaking stress. Okay, got it. So this R is called as a fundamentals. Okay, now discuss the another topic, modulus. So the modulus means the stress by strain is called as a modulus, elasticity modulus. Modulus are classified three types. Okay, three types. That is called as a Young modulus. First we discuss the topic of Young modulus. Okay. So what is the Young modulus? Young modulus. So Young modulus is equal to longitudinal stress by longitudinal strain. Okay, so Young modulus is equal, so that is Y is equal longitudinal stress by longitudinal strain. The ratio between longitudinal stress to longitudinal strain is called as a Young modulus. So Y is equal to F by A by E by L. So F L by A E we can write. So this is called as a Young modulus. And so now another topic is called as a bulk modulus. What is the bulk modulus? Okay, so bulk modulus is equal. Okay, so that is called as a bulk stress by bulk strain or volume stress by volume strain. Okay. Volume strain. So volume stress by volume strain. So that is called as F by A by delta L by or so that is called the delta V by V we can write. So this is called as a bulk modulus. So bulk modulus is equal volume stress by volume strain or bulk stress by bulk strain is called as a bulk modulus. Okay. So now we discuss the another. So that is called as a shearing modulus. Shearing modulus. So what is the shearing modulus? Shearing modulus is nothing but, so the shearing stress by shearing strain is called as a, that is called as a shearing modulus. Shearing stress by shearing modulus, shearing strain is called as a shearing modulus. So that we can write in mathematical form. Okay. So what is the Young modulus? What is the bulk modulus? What is the shearing modulus? Okay, got it. So now discuss the another topic, very important topic. So what is the strain energy? What is the potential energy? And so expression for strain energy. So that is means work done in a deforming a body is stored as a strain energy. Work done in a deforming, okay, work done in a deforming of a body is stored as a strain energy. Now, so the expression for strain energy. Expression for the strain energy. So the work done by the external or by the work done, so against the interatomic forces. Okay, so the work done is stored as a potential energy. Okay, so now we consider the length of the wire is taken L. L is called as a length of the wire. A is the area of the cross section. L is the length of the wire. A is the area of the cross section. And some force, some external force is applied on the wire. So some extended, okay, some extension, some elevation is developed or on the end of the wire. So that is called as a E is taken. E is called as a extension. Okay, good. So some external force is applied on the wire. So interatomic forces against the interatomic forces and some work done. So the work done will be stored as the potential energy. Potential energy. Okay, got it. So now we have considered the wire. So the wire is taken, length is L, and area of the cross section capital A, and FB the force is applied end of the wire, free end of the wire. Okay, so free end of the wire. So that is what as here taken. So the small work done. So small work done is equal dW is equal F into dE is taken. Okay, so the total extension is taken 0 to E, but here small extension, so that is called as a dE. Small extension is taken dE. So the small work done dW is equal force into displacement. So force into extension is dE. Okay, so dW is equal F into dE. Got it? Now here consider the point of length L and area of the cross section A, and so one end is the fixed rigid support and another end is the free end. So some external force is applied on a free end, there some stress is applied on the wire. So through this small extension, that is called as a dE. So small work done dW is equal F dE. Okay, according to Young modulus we can write, so Y is equal F by A, so E by L we can write. So F into L by A, E we can write. Now substituting in the equation, so dW is equal, okay, so F is equal, we can write, so Y is equal F L by A into E. So F is equal Y A E by L we can write. Okay, so that is the F is equal Y A E by L into D. Okay, so now here this is called as a work done for small extension. Now we are taking the total work done. Total work done. Total work done. So up to 0 to E. So integrating on both sides. Integrating on both sides. On both sides. So integrating is taken, integrating dW, so taking limits 0 t, so this is called as a total work done. Okay, integrating dW is equal W. So integrating dW already to find out 0 to E. Okay, so Y A E by L into dE we can write. Okay, so W is equal, so Y is the constant, A is the constant, and L is also constant. So remaining equation we can write 0 to E dE. Okay, so into the power of E is taken 1. Okay, so for example, x to the power of n dx is equal x to the power of n plus 1 by n plus 1 we can write. Okay, integrate of x to the power of n dx is equal x to the power of n plus 1 by n plus 1. Now we are taken this power is 1. Power is 1. Now here substituting 1 plus 1 by 1 plus 1, 2. Okay, after integrating. So limits are go to outside. So W is equal Y A L. So integrating of e to the power integrating ED. So that is called as a e to the power of 1 plus 1 by 1 plus 1, 0 to E is taken. So limits after integration go to outside. This is called as upper limit. This is called as a lower limit. And so the W is equal Y A E power 1 plus 1 is square by 2 into L is taken. Okay, now substituting, so upper limit and lower limit. So E plus E substitute minus E plus 0 substitute. So W is equal Y A 2L E square minus 0 square. So upper limit minus lower limit substitute. So we get final equation. So W is equal Y A by 2L into E square. Okay, now here multiply and divided with respect to, so Y A E square, okay, got it, E square by 12, that is called as a W. Okay, got it. Now here, so the dividing, so Y is the taken angomolus, and so A into L, okay, so dividing with respect to L by L, so A into L writing outside, that is the area into length, that is called as the volume, and E square, here L square, E square by L square we can write, and into 1 by 2 we can write, okay, and so here E square by L, E by L is nothing but change in the length by virtual length, that is called as a strain, okay, E square by L square is strain square, okay, so we can write W is equal of into angomolus. What is the angomolus? Longitudinal stress by longitudinal strain is called as a angomolus, okay, so stress by strain into strain square into volume, okay, got it. So strain is cancelled, so remaining equation we can write of stress into strain, okay, into volume, okay, A into L is called as a volume, so that is the total work done, okay, so this is the total work done is stored as in a potential energy, okay, good. Potential energy, so the potential energy U is equal 1 by 2 stress into strain, so per unit volume, so 1 unit volume, okay, so is taken, that is the volume is equal 1 is taken, so the per unit volume, so the energy stored U is equal 1 by 2 into stress into strain, so this is called as a potential energy stored in the wire, okay, got it. So now discuss the today this class is over, another class we discuss about the, so the load is applying on the wire, so what is the gradual increasing on the load on the wire, so what is the behavior of the wire, okay, so we study about the next class.